Okay, so we're on to Unit 2. This first section is basics of functions and their graphs. And so you can see that this is going to be part 1, so 2.2 will be part 2. And so really this unit is going to be all things functions. And so first we kind of have to start out and define what functions are. So first we're going to define a relation. So a set of ordered pairs is called a relation. A relation can be represented in several different ways. We can use ordered pairs, we can use a table, we can use a graph, and a mapping or an equation. And so here are some examples of that. So right here we have our ordered pairs right here, where we basically just list your x value and then your y value. Or we could just make a table instead. A lot of times students like to do that. It's a little bit easier. And then here is a graphical representation of these points. So right here, this x value is -2, the y value is 4. That's this point right here. So we go back 2 and up 4, land right there. Then 1, 2, forward 1, up 2, or 0, -3. So the x value is 0, and then I just drop down 3 units and I land right there on the y-axis. A mapping, we don't use that too often. A lot of times that's kind of used to explain maybe a concept that's taking place, and so we'll see it a little bit. But what we're doing here is the x values. These are your x values, which are also known as the domain. We're going to talk about that in just a second. These x values are mapped into the y values, the range. And so basically you take this x value and it's plugged into some formula, some function, and it spits out your result right here. So if I plug in a 1, it brings out a 2. If I plug in a -2, it brings out a 4, and so on. And so that's a mapping right there. Okay, so now, as I was telling you, we're going to talk about domain and range. So right here, the x values of the relation are known as the domain. And so you can just list them as a set of values right here. And typically you like to put them in numerical order, but you don't have to. If you don't put them in numerical order, it's not incorrect, but typically we like to go from low to high. And then the y values in the relation are known as the range. And so you can see there are all the y values from the ordered pairs, the table, the graph, the mapping. So you can see those values are right there. Okay, so then what makes a relationship a function? Well, for a relationship to be a function, there must be only one output for each input of x. Simply, x cannot have more than one partner. So for each x value, you can only have one unique partner. Okay, if these conditions are met, we say that y is a function of x. Okay, so let's kind of look at a couple examples of this where we can see what is a function and what's not a function. So right here, let's see. So my input is the x value and the output is the y value. So when I input a 1 for x, I get a 2. If I put input a 3, I get a 3 back. If I put a 4, I get a 5. If I put a 4, I get a 7. Okay, there lies my problem. So right there, this is what this is saying in the up here above is I can only have one output for each input of x. So right here, when I input 4, I'm getting back 5 and 7. And so that's a problem. I can only get one unique value in return. So is this a function? No. Okay. Now, even though it's not a function, it's still a relation, and it does contain a domain and a range. So the domain would just be the x values. So let's see, that'd be a 1, a 3, and a 4. And then do not put 4 another time. I know 4 is there twice, but whenever you list it, you don't want to list it twice. If it shows up twice, you just list it once right there as part of your domain. Then the range is the y values. So let's see, what do we have here? We have a 2, a 3, a 5, and a 7. So that's my range. Okay, looking at example B, so let's see, if I plug in -1, I get 1. If I plug in -2, I get 5. If I plug in 4, I get 5. If I plug in 6, I get 7. Let's see, is this a function? You might be thinking, no, it's not. Look, the 5 repeated, just like over here, the 4 repeated. Well, it's okay for the y value to repeat. The x value just cannot repeat. Okay, so that's kind of another key way of finding this is that if your x value repeats, you know you're not dealing with a function. But if you look here, each x value is unique, and so I'm okay. So this is a function, so yes. And so let's see, my domain is going to be the x value. So let's see, it's going to be -1, -2, 4, and a 6. Okay, and then the range values, let's see, they're going to be 1, and then once again that 5 shows up twice, but that's okay. And just list it once, and then 7. Okay, so if you're still kind of a little unsure about what's a function, what's not a function, we're still going to talk a little bit more about this, and hopefully we'll kind of fill in any gaps you might have on this. So we're going to talk about what represents a function in terms of a graph. And so in order to do that, we use a thing called the vertical line test. So right here, to be a function, every x value can only be paired up with one y value. Okay, so we kind of already talked about that. So each x value can only have one unique y value. And so the problem on part A was my x value had two separate partners. So 4 was partnering up with 5 and 7. On example B, the y value 5 was partnered up with two different values, but that was okay. That was okay. And so hopefully this will make a little bit more sense when we start looking at this in the graph. So therefore, so right here, so to be a function, every x value can only be paired with one y value. Therefore, if any vertical line intersects the graph at more than one point, the graph is not a function. To run this test, just drag a vertical line across the graph. So that's what I'm going to do here. I'm going to grab a vertical line here. And so you can see right away on this first one, this is causing a problem. I'm touching the graph at more than one spot. So if the vertical line intersects the graph at more than one point, it's not a function. And so I'll kind of show you why here. I'm going to go ahead and stop right there. And see, it's intersecting it right here and right here, right? And so I'm just going to kind of estimate that this ordered pair, it looks like I'm going over about maybe 2 spots, and then I'm going up about 2 spots. So when x is 2, y is 2, right? Well, wait a second. No, over here, this one's saying that when x is 2, y is -2. And so that's a problem. I'm getting conflicting results, right? We typically like to plug in x, and the return value is kind of something that we're interested in, maybe some data coming back. And the problem here is my data is coming back with two different results, and so that's why it's not a function. It does not qualify as a function. So this one is going to be no, not a function. All right, let's look at the next one. So let's see, we'll take my vertical line here and drag across. It looks like I'm just touching at one point the whole time. So that's going to check out. That one's going to be okay. So that one would qualify as a function. Is it a function? Yes. Then let's see this next one. Let's see, I'm touching at one point. Looks like example C is okay. So that one's going to be a function. Yes. All right. And so then my last example D right here. Let's see. Right there, it's only touching at one point, but right as I move over, uh-oh, I'm touching at 2 points. Not good. Not good. So once again, it's kind of the same thing as my other one. I'll just stop right there. Right here, when x is, whatever, the problem is I'm getting two different results. Okay? And so that's going to be no. That does not qualify as a function. Okay, not to say that it's not a relation. Okay, there is a way to come up with an equation that represents this relationship right here. But what you'll notice is we're going to focus only on functions, though, in this unit. Okay, so one really important thing that you're going to see throughout this unit and the other units is this thing called function notation. So right here, the equation that are functions can be written in the form called function notation. So for example, if you have y equals 3x minus 8, we can actually take that equation and rewrite it as a function notation. What we do is we basically just replace the y with an f of x. And to be honest, it's just kind of a convenient notation for us, okay? And so we pronounce this f of x. Okay, so this is pronounced f of x, not f times x or anything like that. It's f of x. And this notation, for example, if I wanted to plug x into the equation, okay, if you look at the equation, if I want to plug x in, I'd say, well, let's let x equal 5 and so on, and then I would go ahead and solve for y. Well, with function notation, you can just go ahead and do f of, and you plug in what you want to plug in. So f of 5. So basically this is saying let x equal 5. So I do. So 3 times 5 take away 8. 3 times 5 is 15. 15 take away 8 is 7. So therefore, when x equals 5, y equals 7. And if you want to, you could even write it as an ordered pair, 5 comma 7. So that's our function notation. There's a couple reasons for doing this, but like I said, it will show up from here until the end of the semester. So right here it says evaluate each function at the given values of the independent variable and simplify. So I'm given this function right here, f of x equals 4x plus 5. So the first one's asking me what is f of 6. So f of 6, I just substitute 6 right there. So it's going to be 4 times 6 and then plus 5. Well, 4 times 6 is, let's see, what is that, 24? Then we'll add 5 to that, and I get 29. And so that is going to be my answer right there. That is my answer. Now, if you really wanted to, you could write it as an ordered pair, but we're not really going to, on your homework, they're not going to ask for that. They just want you to plug in the final result. So your answer would just be 29. Okay, sometimes we're plugging in expressions, not just a value. So right here, they want us to plug in x plus 1. And so that's exactly what I'm going to do. I'm going to plug that in right there. So f of x plus 1. And so I'm plugging in 4 times x. Instead of 4 times x, it's going to be 4 times x plus 1. And then don't forget that plus 5 on the back part of that. So whatever you're evaluating the function, if that's what you replace the variable with. So instead of an x, it's actually an x plus 1, and it's important to put that parentheses around it because that 4 now needs to get distributed to those two values right there. So this will become 4x plus 4, and then don't forget about the plus 5. And then we can go ahead and add the 4 plus 5, which is a 9. So we get 4x plus 9 and stop. That's our answer right there. A very common mistake students will do is all of a sudden they'll add like an equal sign and they'll try to solve for x. And so we don't want to do that. We don't want to do that. You want to plug in what you're evaluating the function at and then simplify it and then just stop right there. Now on example C right here, we're going to plug in negative x. Okay, and in previous videos we might have talked about this, but negative x is short for negative 1 times x right there. It's the same thing, negative 1 times x. So we're going to plug this in. So we're going to have f of negative x is equal to 4 times negative x, and then don't forget about the plus 5. And so as I mentioned, that negative x is equivalent to negative 1 times x. So really what you're doing is you're going to multiply 4 times negative 1. So this is going to become negative 4x, and then we have that plus 5 right there. And that's our answer. All right, let's try a couple more of these. So on my example 2 here, let's see. So I have the function f of x is equal to x squared plus 2 times x and then minus 3. So when I plug in f of 2 right here, I do need to plug that in everywhere I see x. So this is going to become 2 squared plus 2 times 2 and then minus 3. So I plug that 2 in everywhere I saw it. And then now it's time to go ahead and simplify this. So 2 times 2 is 4, plus 2 times 2 again is 4. And then take away 3. 4 plus 4 is 8. Take away 3 is 5. And that's it. That's my solution. All right. So let's go ahead and look at B. So I'm going to plug in negative 2 now. So this is going to be negative 2 squared plus 2 times negative 2 and then minus 3. All right, so let's see. Negative 2 squared, negative 2 times negative 2 is positive 4. And then plus 2 times negative 2, that'll become a minus 4. And then minus 3. All right, well, 4 take away 4 is going to be 0. 0 take away 3 is negative 3. And that's what it simplifies to. So the function, when evaluated at negative 2, results in negative 3. All right. Now, example C, we're plugging in the x plus 5. So I'm going to plug that in everywhere I see right here. So that's going to be x plus 5 squared plus 2 times x plus 5 and then minus 3. Okay, so I'm just plugging in the x minus 5 everywhere I see x. All right, so let's talk about this because there's a common mistake that occurs here. A lot of times students think that x plus 5 squared is equal to x squared plus 5 squared, and that is not correct. So you don't want to do that. You don't want to do that. So think about this. If I were to ask you, what is 5 squared? You'd say, well, that's 25. And I'd say, well, why? Why is it 25? Well, 5 times 5, right? And if I did 5 to the power of 3, you would do 5 times 5 times 5, right? Okay, well, this is going to work the same way. The x plus 5 squared, that's going to be x plus 5 times x plus 5. And so you're going to have to go ahead in a moment and FOIL this. We're going to FOIL that in a moment. But let's see, what else do I have here? I have plus 2 times x plus 5 and minus 3. I don't want to forget about all that stuff. Okay, so now I'm ready to FOIL this. So let's see. X times x is x squared. X times 5, that would give me a plus 5x. 5 times x, that gives me another 5x. And then 5 times 5 is 25. Okay. I can go ahead now and distribute this 2. So let's see, that'll give me plus 2x plus 10. And then let's not forget about that minus 3 that was on the back part of that. So then it's just time to clean this up. It's time to go from high to low on your powers and on consolidating your terms. So x squared, I only have a single x squared, so I'll just go ahead and write that down. Then what about my x's? Let's see, how many x's do I have and where are they? So let's see, I have 5x plus 5x plus 2x. So I'll consolidate that all together to be a total of 12 x's. Okay, and then last, let's see, what do we have here? I've got plus 25. Let's see, plus 25 plus 10 minus 3. Well, 25 plus 10 is 35. And then if I take 3 away from that, that would leave me with positive 32. So plus 32. And so that's what this simplifies into. And then we just want to go ahead and just leave it like that. Okay, and that's what you'll do. That's what you'll type in on the computer. All right, let me erase this from earlier so that we can do example D. All right, let me scroll up so I can see the original. There we go. And so I'm going to plug in that negative x right there. So this is going to be negative x squared, then plus 2 times negative x, and then minus 3. Okay, so as stated earlier, that negative x has that understood 1 with it. So it's really like negative 1 times x. Okay, so whenever I square this, the negative 1 times negative 1 becomes positive 1. And then x squared is x squared. So I end up with 1x squared, or I'll probably just end up writing it like x squared. I don't really need to put that on, the times 1 out in front. Then right here I have plus 2 times negative x squared. So this will become plus negative 2x, right? 2 times negative 1 is negative 2x. Then plus a negative, it's nicer if I just write it as a minus 2x. So if you're adding a negative, for shorthand, you can just go ahead and put minus 2x, and that's what we like to do. And then last, we just have that minus 3 that kind of comes along, but I don't really have any like terms to combine, so this is what it simplifies into. So when I evaluate the function at negative x, my result is x squared minus 2x minus 3. Okay, so I'm going to go ahead and stop here and make another video to continue on.